Craft Software Solutions team presents you a simple guide for software development. When to use what? So, as the topic suggests, this presentation is mainly focused on how to choose a software development model to optimize our needs and resources. First, we will take a quick peek into the main things that you should consider before selecting a model. The development team is one of the main factors that need to be analyzed. Working in parallel requires a huge team, but a quick product can be released, and the cost is high. A single person can do it, but will take a longer period, though the cost will be less. Likewise, the qualities of the development team should be analyzed first. Primary goal is something relevant to the final output of the product. A small-scale software can be developed using a very simple iterative model, but a large-scale software with facilities such as networking needs to be developed by a complex model like the Agile model. Customer relationship is also important. Some models are basically focused on customer relationship, but if the client is busy, then such models should be discarded. Models such as the Agile model and the RAD model requires large capital, while models like Waterfall model and Iterative model needs not much. Therefore, the amount that the client hopes to invest should be reconsidered. The time requirement is also a vital factor. Models like the RAD model can be used to develop quick products, while the waterfall model will slow down the process. Likewise, we must consider every aspect and select the optimal model that suits our needs.
So, in this presentation, we are going to do is we introduce some scenarios and we mention some models that can be applied for those situations. So, the first situation is requirements of the complete system are clearly defined and understood, and major requirements must be defined, but sometimes some details can evolve with time, and also a new technology is being used. Less complexity, and also there are some high risk features and goals, and there is a need to get the product to the market early. So I will introduce you a model that can be applied for this scenario. So the model is incremental model. In incremental model, I will introduce you the idea of the incremental model, advantages and disadvantages of the incremental model. So the idea is the whole requirements is divided into various builds, and then each build is separated, separated and builds separately. So then after finish, then each build is joined and build the successful product. So cycles are divided into smaller, more easily managed modules. Each module passes through the requirement, design, implementation and testing phases. Then the thing is, a working version of the software is produced during the first module. So you have working software early on during the software life cycle. And also each subsequent release of the module adds functions to the previous release. The process continues till the complete system is achieved. As example, you can understand using this diagram. In the diagram, when we work incrementally, we adding piece by piece, but expect that each piece is fully finished. Thus keep on adding the piece until it's complete, as in the diagram. That's the idea of incremental model. So then we will discuss the advantages of the incremental model. The major advantage is the system is more flexible. That means less cost to change scope and requirements, and easier to test and debug during a small iteration. Also easy to manage because risky pieces are identified and handled during its iteration. And also low initially cost. That are those are the advantages of the incremental model. So then we look at the disadvantages of incremental model. Sometimes total cost is higher than the waterfall method because we have to divide it into the requirements and we have to add the requirements. So there is extra cost to that. And also we need good planning and design because we have to divide the whole requirements. And also need a clear and complete definition of the whole system before it can be broke down and built incrementally. So that is the incremental model and the first case. Thank you.
Okay, now I'm going to talk about the Rapid Application Development Model. Rapid Application Development, or RAD, is a software development method that uses minimal planning in favor of rapid prototyping. Here, the lack of extensive pre-planning generally allows software to be written much faster, and it makes it easier to change requirements. There are 4 phases of RAD. The first phase is requirements planning phase. Users, managers, and IT staff members discuss and agree on business needs, project scope, constraints, and system requirements. It ends when the team agrees on the key issues and obtain management authorization to continue. Then comes the user design phase. During this phase, users interact with system analysts and develop models and prototypes that represent all system processes, inputs, and outputs. The third phase is construction phase. Here we focus on program and application development tasks similar to the SDLC. In RAD, however, users continue to participate and can still suggest changes or improvements as actual screens or reports are developed. Its tasks are programming and application development, coding, unit integration, and system testing. The final phase is the cutover phase. Here we resemble the final tasks in SDLC implementation phase, including data conversion, testing, changeover to the new system, and user training. So as you can see, compared with traditional methods, the entire process is compressed. And as a result, the new system is built, delivered, and placed in operation much sooner. So generally, Rapid Application Development method promotes strong collaborative atmosphere and dynamic gathering of requirements, which is a plus point. On the other hand, it has a lesser degree of centralized project management and engineering authority, which may lead to huge negative results.
Think of a situation when the requirements are clearly defined and well understood, but the project is very large and high risk. So, it is hard to design the entire system in advance. A better model which can be used in this situation is Iterative Model. In this model, we take the large system and figure out some way to partition it into smaller components. The work activities are done once, then again and yet again on different components, producing a new version of the system at each iteration. The process is repeated until the system gets closer to what is ultimately expected. There are 2 major ways of defining iterations. One approach is to define key functions, design and implement them at the first iteration. The next set of required but less crucial functions are then implemented. The process repeats and finally some optional functions are added. Another approach is to focus on one subsystem at a time. The whole system is partitioned and each subsystem is developed in an iterative manner. The iterative model does not attempt to start with the full specification of requirements. So, many popular other approaches use this as a fundamental element. Let's look at some advantages of iterative model. Since we can track the defects of each iteration, we can avoid downward flow of them. It is very easy to get client feedback by presenting sketches and blueprints of the system at each iteration. There are some disadvantages as well. Each phase of iteration is rigid with no overlap. This model may require expensive system architecture.
There are various kinds of software development models such as waterfall model, V model, incremental model, RAD model, agile model, iterative model, spiral model. So our big idea is we have to use the correct model in order to finish our software very fast. If we don't select the correct model, we will end up with a half developed software. If we finished, it will be a very bad software. Also, the model has a high impact on the testing.
So, that's what we expected to give from this presentation. Thank you.